Good morning, all. Today we are going to see about the topic 8051 microcontroller, which belongs to Embedded Systems and IoT subject. The subject code is 231CS522. It is comes in fifth semester. So next we are going to the topic. So these are the outline of the presentation. Introduction, architecture, the explanation of the architecture, and pin diagram, then addressing modes. So first we are going to see about what is mean by microcontroller. A microcontroller is a small and low cost microcomputer which is designed to perform the specific task of embedded systems like displaying microwaves information, receiving remote signals, etc. The general microcontroller consists of the processor, memory. The memory is known as ROM, RAM, and EPROM, serial ports, and peripherals like this. Intel introduced an 8-bit microcontroller called the 8051 microcontroller. It is used in most popularly in the embedded system environment. So here the difference between microcontroller and microprocessor are given. In microcontroller are used to execute a single task within an application. Microprocessor are used for big applications. It is designing and hardware cost is low compared to microcontroller. The cost is high in microprocessor. It is easy to replace. Microcontrollers are easy to replace. Microprocessors are not easy to replace. In microcontroller, it consists of CPU, RAM, ROM, and I/O parts. In microprocessor, it does not consist of RAM, ROM, I/O parts. It is uses its pins to interface to peripheral devices. It is built with CMOS technology, which requires less power to operate. Its power consumption is high because it has controlled the entire system. Then features of 8051. In 8051, it is known as 4 KB on-chip program memory, 128 bytes on-chip data memory. Here, four register banks it have 64 KB each program and external RAM addressability. Then 32 bidirectional input-output lines organized as four 8-bit ports. It has multiple modes, high-speed programmable serial port. Then 16-bit timer or counters it have. Direct byte and bit addressability in 8051 microcontroller. The applications of 8051 microcontroller. It is used in light sensing and controlling devices, the temperature sensing and controlling devices, fire detection and safety devices, automobile applications, and defense application. Next, we are going to see about the architecture of 8051. In this architecture, we have we have internal buses. We have internal buses. Internal buses are the is known as the connection between the internal parts. So in this 8051 architecture, we have CPU, oscillator, and then interrupt control. Interrupt control is used to control the interrupt from the outside, that is external interrupts. It should be controlled. Then it has on chip ROM. In on chip ROM, we have to store the programming code. Then on chip RAM. In on chip RAM, it is used to store the process of the particular instruction. Then timer, it has timer 0 and timer 1 to control the inputs, and bus control. Then four input and output ports. Next is serial port. In serial port, we have TXD and RXD. TXD is known as the transition data and RXD is known as the receive data. Then in next slide, we are going to see the explanation of the entire architecture. So first one, CPU. CPU is known as Central Processing Unit. It controls all operations in the microcontroller. It executes instructions from program memory. Then next one, oscillator. Oscillator is used to generate clock pulses. Typically uses 11.0592 MHz crystal for timing. It provides timing for entire microcontroller. Then interrupt control. In interrupt control, it supports external interrupts. It is denoted as INT0 and INT1. Interrupts allow immediate attention to important tasks. Next is on-chip ROM. In on-chip ROM, the program's code is stored in permanently. The ROM is known as read-only memory. Then on-chip RAM, it is known as random access memory. The data is stored in temporarily in during the program execution. It is used for variables and stacks. Then internal bus, it connects all blocks and transfer data internally, like a highway for data inside the 8051 microcontroller. Next, bus control. It is used to manages data and address flow on the internal and external buses. It also helps in multiplexing address and data. Input and output ports. Four ports are here used for input and output operation. That is port 0, port 1, port 2, and port 3. It is used to connect external devices like LEDs, sensor, switches. In some pins have the multiple functions. Next, in serial port, we have two functions, TXD and RXD. TXD is used to transmit data. RXD is used to receive the data. Next, timers. In timers, we have timer 0 and timer 1. It is used to generate time, delays or count external pulses. It control using the software. Then counter inputs. It is used to timer to count external events. Next, we are going to see the pin description in 8051 microcontroller. In 8051 microcontroller, have 40 pins. It is known as DIP IC, that is dual in package integrated circuit. Uh, in this, we have a rectangle shape IC. In this one side, we have 20 pins and another side, we have 40 pins. So next, we are going to see the function of the pins. So pin number 1 to 8, these pins are known as port 1. It is called as port 1. This port does not serve any other functions. It is internally pull the bidirectional input and output port. Then P9, it is known as the reset pin. It is used to reset the microcontroller to its initial values. Pin number 10 to 17, these pins are known as port number 3. These port serves some functions like interrupts, timer input, control signals, serial communication signals like RxT and TXT. Then pin number 18 and 19, these pins are used for interfacing an external crystal to get the system clock. That is the oscillator. In this architecture, we have an oscillator a portion. In this portion, we have to connect 18th and 19th pin to make the system clock. Next, pin number 20. It is used to provide power supply to the circuit. That is, it is the known as the ground pin to connect to the ground. Next, pins 21 to 28. These pins are known as port 2. It serves as input and output port. Higher order address bus signals are also multiplexed using this port. Pin number 29. This is PSEN pin, which stands for Program Store Enable. It is used to read a signal from the external program memory. Next, pin number 30. This is called as EA pin. It is EA is known as External Access pin. It is used to enable or disable the external memory interfacing. Next, pin number 31. This is ALE pin, which stands for Address Latch Enable. It is used to demultiplex the address data signal of port. Pin number 32 to 39. These pins are known as port 0. It serves as input and output port. It is a lower order address and data bus signals are multiplexed using this port. Next, at last we have pin number 40. In pin number 40, it is used to provide the power supply to the circuit. In my 8051 microcontroller has plus 5 volt. It is if we have plus 5 volt power supply, now it will work. Next, we have uh, four input ports, that is port 0, port 1, port 2, and port 3. So, first we are going to see about port 0. The PO, port 0 is characterized by the two functions. When the external memory is used, then the lower address byte is applied on it. Else, all bytes of this port are configured as input and output. When P0, that is port, is configured as an output, then other ports consisting of pins with built-in pull-up resistor connected by its end to 5-volt power supply. The pins of this port have this resistor left off. Then port 1. Port 1 is a true input and output port. It does not have any alternate function in port 0. It has built-in pull-up resistor and it is completely compatible with TTL circuits. Next, port number 2. It is similar to port 0 when the external memory is used. Pins of this port occupy addresses intended for the external memory chip. This port can be used for higher address byte with addresses A8 to A15. When no memory is added, then this port can be used as a general input and output port similar to port 1. Then next one, port 3. In this port, functions are similar to other ports except that the logic 1 must be applied to appropriate bit of the P3 register. Next, we are going to see about the addressing modes of 8051. What is meant by addressing modes? If the way in which an operand is specified in the instruction is known as an addressing modes. It is denoted as how we represent the data in assembly language. And thus we have 5 addressing modes. Here we are going to see the classification of addressing mode. First one is immediate addressing mode. Then second one, register addressing mode. Third one, direct addressing mode. Fourth one, register indirect addressing mode. Fifth one is indexed addressing mode. First one, immediate addressing mode. In this immediate addressing mode, we are directly specify the source operand. It has an 8-bit microcontroller, so we have to represent the 8-bit data. It can be specified. The immediate data will be followed by the symbol hash. If, for example, we are taken move a comma hash 04h. In this, we are, hash 04 we are representing. 04 is the data because we are representing hash symbol before the data. So the this particular data is moved to the accumulator A. So here before execution the value of A is 09. After the execution the value of A is 04 because the data 04 is moved to the address A, sorry, accumulator. Then next one is register addressing mode. In this, both source and destination operands are registers. Move A, comma R0. The data which resides in R0 register is moved, copied to A register. Before execution, the value of A is 0C, then the value of R0 equal to 09. So after execution, the value from the register, it is moved to the accumulator. So the value of A is 09, the value of R0, that is register 0 is 09. Next, direct addressing mode. In this addressing, in this addressing mode, the address of the data is specified either in source operand or destination operand. That is, for example, move R2, comma 04. This here 04 is represent the address of the memory location. But we are giving the hash symbol means it is considered as data, but without hash, it is considered as memory location of the register. So only the internal memory address 002 will be used in this mode. Before execution, the value of R2 is equal to 09. After execution, the value of R2 is changed into OC because in O4 we have the value as OC. So it is changed into the moved into the R2 register. Next, register indirect addressing mode. In as the name itself, we have the address of the memory location which contains the data is specified by registers. Here we are using the at symbol to specify the addressing mode. Only R0 and R1 register can be accessed via this mode. In this example, we have move A comma at R0. Assume the R0 register is pointing to location 80H. Then the value say 0E in 80H is moved to A register. Before execution, the value of A is equal to 0C. Then after execution, the value of A is 0E. Next, indexed addressing mode. In this mode, the effective address is formed by summing up the base register and accumulator register. The base register, that is program counter, and DPTR, data pointer register. The destination operand will be always A register. The source memory can be accessed only by program memory, which is represented by letter C. For example, we have move C A comma at A plus PC. Assume the A register holds the value of 07H and the PC has the value 4100H. Then the data memory location is 4107H. This moved to the register A. Okay. Uh, in this in this presentation, we are seen about the architecture of. First one, we are seen about the what is mean by microcontroller, then the difference between microprocessor and microcontroller, and then the architecture of 8051 microcontroller and the pin description of the 8051 microcontroller. At last, we have seen about the addressing modes used in the microcontroller. So, in next we are next time we are going to see another topic. We are going to meet in another topic. Thank you.